How to fix multicollinearity in your regression models. Imagine trying to listen to a conversation where everyone is talking at once. That's what multicollinearity can do to your regression models. It makes it hard to tell which variable is really influencing the outcome. So, how do you clear the noise and get your model to speak clearly? Let's explore some practical ways to fix multicollinearity in your regression models. First, look at the correlation between your variables. If two or more are highly correlated, consider removing one of them. You can check this with a correlation matrix or calculate variance inflation factor scores. Variance inflation factor tells you how much a variable's variance is inflated because of multicollinearity. If the score is high, say above 10, it's a sign you should think about dropping that variable. Removing redundant variables simplifies your model and makes your coefficients more reliable. Next, think about combining correlated variables into a single predictor. Techniques like principal component analysis or factor analysis help with this. They create new variables, called components, that capture the shared information of the original variables. This reduces multicollinearity while keeping the important information in your data. It's like turning many noisy voices into a single clear one. Another effective approach is to use regularization methods like ridge regression or least absolute shrinkage and selection operator, or LASSO. These techniques add a penalty to the regression to shrink the coefficients of correlated variables. Ridge regression pulls the coefficients of related variables closer together, while LASSO can shrink some to zero, effectively removing them from the model. This way, you keep all your variables but control the impact of multicollinearity. Sometimes, simply centering or standardizing your variables can help. Subtracting the mean from each variable or dividing by the standard deviation can reduce multicollinearity caused by polynomial or interaction terms. But remember, this doesn't fix multicollinearity from variables that are naturally correlated. Gathering more data can also help. If possible, collect data in different conditions or over a longer period. This can weaken the relationships between variables and reduce multicollinearity. It's especially useful in experimental setups where you can control the data collection process. Finally, consider partial least squares regression. This method transforms your predictors into new orthogonal components that maximize the covariance with the response variable. It's especially handy when your goal is prediction rather than interpretation, as it handles multicollinearity by focusing on components that explain both the predictors and the outcome. In the world of artificial intelligence and machine learning, especially in supervised learning where models learn from labeled data, fixing multicollinearity is key. Regularized regression methods like ridge and LASSO are popular because they work well with many features. Dimensionality reduction techniques like principal component analysis are often used before training models to make the data more manageable. Tools like ChatGPT or productivity plugins can help automate the detection of multicollinearity and suggest the best fixes, saving you time and effort. Just be mindful that removing or transforming variables should not eliminate important information or introduce bias. Always check your model after making adjustments to ensure it remains accurate and fair. So, whether you're building a simple linear regression or a complex machine learning pipeline, these strategies can help you create more stable, interpretable models by tackling multicollinearity head-on.